Welcome back to my channel. I'm Brian Kafke, and we're continuing the Master Databricks and Open Source Apache Spark series. In this one, we're talking about using PySpark but leveraging SQL. A lot of this material, by the way, I got from my great book, Master Azure Databricks Step by Step, so you can get that available on Amazon. Let's jump in. This is going to be a very code-centric video, so I want to walk through a few things here. Again, always vet test code before you use it, to make sure that it doesn't do anything you wouldn't want happening in your environment. The first question you may be asking is, why would I want to use SQL when I'm using PySpark? I mean, isn't PySpark awesome? Isn't Python everything we ever want? Python is great, but you'd be missing a lot in the Spark world if you ignore SQL. In fact, the real direction that Spark has been going in for a number of years now is to create better and better and better support for SQL and SQL tables and views and things like that. It's competing against products like Snowflake, and the need for organizing data and putting it into a nice, easy to use and consume place like tables and use things like SQL is paramount. So that's one of the reasons. It's central to Spark's direction. And if you've seen things like Delta Lake and Parquet and all this stuff, that's all built around Spark SQL tables. One of the things that I really want to call your attention to is that I like about it is many times your data will be in a Delta Lake, right? It'll be in these different tables in Delta or something. And it's nice that you can use SQL to query, join, and do things with it and bring it back as a PySpark data frame. So it kind of is a nice way to just get the data quickly. SQL is also a very expressive and powerful language. It's one of the reasons why the creators of Spark decided to include SQL as a foundational language in Spark. The expressive part meant that the parser within Spark could interpret what you're doing in an SQL statement and optimize it for things like when you sort or filter or join. And that tells you that if they can automate something like that and then create a plan based on that to make it efficient, it must be pretty easy to read. Thirdly, everybody knows SQL. My Aunt Edna knows SQL. So the question there with SQL is, everybody knows it. So if you use SQL, you don't have to worry about all the different languages people may be comfortable with. Some people may say, I only like to use R. Some people say, I want to use Scala. But SQL has to be a common denominator. Anybody who does data work these days needs to know SQL. SQL tables are an ideal place to store and query data. And that's enough said because I mentioned Delta Lake and Delta tables, and Delta is where everything's going. SQL tables and views can be accessed from any Spark language. That's kind of a little subtle thing that you may have hit if you've used Spark to this point. But you'll notice that if you create a data frame and say R, and then you try to read that data frame from Python, you can't. There are actually different shells within the same Spark environment, and so they can't really talk to each other when it comes to the data frames. However, they can all leverage Spark SQL, which means you can take a data frame from, say, R or Python, persist it as a table in SQL, and then you can read it from the other languages. So those are some of the great reasons to use Spark SQL, and the nice thing, as I've said many times, is Spark SQL is guaranteed to perform really well. Now, before you can run the code I'm going to demonstrate, you're going to need to go back to lesson 9 and create the SQL tables on Databricks if you haven't already been doing this. But I know you've been following this video series video by video, so you should be okay. If you're using the open source Spark with Zeppelin notebooks, I'll put the link in both of these in the description. There are two types of data frames you should be aware of when you're working with Spark. One of them is a local data frame, and the other is a distributed data frame. Local data frame is the one we all know and love that you're used to, like a Pandas data frame. Pandas data frame is contiguous. It sits in memory on a single machine in a single process, okay? It's all by itself, just running. And as a result, they typically can't be very large. If you run them on your laptop, it's going to crash your machine if you exceed the memory you have on your laptop. And that's one of the limitations of a Pandas data frame. A Spark data frame is distributed. What do you mean by that? Well, the idea is it takes this very large set of data, a trillion rows, and it chunks it out. So you're going to say, okay, I'm going to give the first 100,000 to this node. I'm going to give another 100,000 to that node and another 100,000 here until it's spread out this data on a number of different machines under the covers. And what's nice about that is then it can say, okay, go, and each machine or node, and it's technically not a machine, it's just a process, but each process can run at the same time in parallel, but only working on a small chunk of the data. That means that it can be a lot faster. It's breaking up a large job into small pieces. You're going to need to use both of these because When you want to do heavy-duty workloads, obviously on Spark, you're going to want to use distributed data frames. But you're going to need to return the results often to a pandas data frame. Why is that? Well, as I said, pandas is all in memory in a single place. And guess what? The libraries, the open source libraries in Python that are used to working with pandas data frames like scikit-learn or Seaborn for visualizations or matplotlib, they don't understand Spark distributed data frames either. They don't know that data is all over a place on this cluster, so you wouldn't be able to use them. So instead, you need to take whatever you need from the Spark data frame and return it as a local data frame before you can use those open source packages. Now, because it's so important to keep a distinction between local versus Spark data frame, and even that matters since they can't be read between what language it's in, I came up with this neat little way to prefix my data frames that you're going to love. What I do is I use the first character and I say, is it an S Spark data frame or L local? So I will, if I know I'm creating a Spark data frame, I'll prefix it first with S, local L. Second character is going to be for the language, P for Python, R for R, and S for Scala. Very clever. And then I just basically put DF there because then I know, oh, okay, S, Spark, P, Python, DF, Spark data frame. Spark Python data frame. I put a little underscore to separate the rest of the word, and then I just add something descriptive for the data frame. So for example, SPDF underscore sales summary means that this is a Spark Python data frame containing sales summary information. So pretty straightforward, but it lets me keep track of things because one thing to be aware of is if I try to take a trillion rows sitting out and distributed over the cluster and bring it back and make it into a local pandas data frame, I'm probably going to crash the entire cluster, and it's not a pretty thing. So you don't want to do that. You got to be careful of that type of thing. When we created our tables, we created them in a database called AW Project. So the first thing we're going to do is switch context to AW Project. What I'm going to be doing to execute SQL statements, and this is a Python cell. I say Spark SQL, and then I just pass in the SQL statement as a string. So I'm going to say change the context to my database AW Project, and then I want to run a query. Spark SQL again. Select asterisk from Factor Internet Sales, and I'm going to drop any rows that have NAs in them. Great. I'm going to return that to SPDF underscore sales info. So that's a Spark Python data frame with sales information in it. And you can see if I go in here, it even gives you a nice list of what columns are created in the data type. Now what happens if I try to display it? Well, it just gives me the structure, basically the metadata about the data frame. It's distributed, and it's not going to actually execute and give results back unless I really force it to. It's a part called lazy evaluation. However, there's a cool feature of Databricks notebooks called the display statement. So I can say display and then put a data frame in parentheses, and it's going to return some of the results back to my notebook. It's not all the results right off the bat. It's going to return some of them though, and that's kind of nice. We'll get some rows back and we can take a look at it. Now you have to be a little bit cautious when you do this. I can look over here and see the data. This is the actual data that came back. And notice it says it only gave me 1,000 rows back because of the problem I mentioned. It's trying to make sure it doesn't crash the cluster. Now, if I go back here, I can go in and use the visualization, the plot options, and I can do whatever I want. But I want to show you something. I had originally done this before. I dragged sales territory here, sales amount here, but it's looking and saying, wait, I'm not going to just do anything. I'm going to aggregate this. I'm doing a visualization, and Databricks is smart enough to say, I don't want to bring back 1 trillion rows when a visualization is automatically going to need to aggregate. So let me restate the query and make it work for the visual. And that's a key thing. It's going to actually have to re-execute your query. So here I said sum, and it's got what it needs. And I'm going to say apply. And it's a bar chart. So I'll go with that. Apply. And it's going to warn me, are you sure you want to do it? Because this action will run your query over the entire data set. In other words, if I had a petabyte of data that it needs to go over, it's going to execute the entire petabyte of data query. So I'll say confirm, and it comes back and it's going to run that query, and there it is. So fortunately it worked and it was able to do that, but remember it did an aggregated query, so it changed. It actually is no longer showing me this data set. Instead, it changed the query and re-executed it so that it brought back only a summarized set of data, which was a lot less to return. Pretty smart. Here I'm going to be doing a little more complex query to kind of give you the sense of why it's kind of handy. Again, you want to jump in and start doing some cool stuff with PySpark data frames, but you need to pull some tables together. So you want to get some columns from different tables. You want to join dim customer to the geography table so that you can look at things like country region, and you want to only get US. So you're going to filter on that. So I'm filtering I'm joining, and guess what else I'm doing? In addition to pulling columns in, I can use special SQL functions. In other words, SQL has an entire library of scalar, meaning row by row, or aggregate functions, we'll see a little bit later, that's really cool. So I'm able to take advantage of all of these language elements from within Python. Now granted, we want to use Python too, but I want to show you can do this. And because again, it's SQL, it will perform really well, even when it's running the upper function. Let's run this query and see how it works. We're going to call the query by just running Spark SQL and passing that string name into it, and return the results to this data frame. Then we'll do a display on that data frame and see how that goes. All right, so that worked great. You can see here all the actual output format of what it returned. You can see the data frame results here. And you could, of course, visualize it and do all those great things. You can also use the columns property to just get a list of column names if we ever forget what are all the columns that are in a data frame. We're going to try a different thing here. What I want to do is I want to create a new column that's a calculation of other columns in my data frame. Now in Pandas, you can do this pretty easily because Pandas data frames are actually mutable. One of the things to bear in mind is that Spark data frames are immutable. More importantly, they're distributed. So it's not a simple thing to just say, I want to add a column or change things. So instead, what we can do is we can add a column, but it will return a new data frame. So we're going to here take our data frame name and say with column, give it a column name, and here's our calculation. We're going to divide the tax amount by the sales amount to get the tax rate. So maybe we want to see what is the tax rate and then display that. So we now know based on province, state province, what is the tax rate. We're going to return the results though to the same data frame name again. I could create a whole new data frame name, or I can just replace the one I have. And that's what I'm going to be doing here. Okay, and it comes back and gives us a list of the columns. Just to see that it worked, I'm going to use the display, but I'm going to use this approach where I can say, here's the name of the data frame. And then as a nested list, a list within a list, I pass a list of the column names I want to see. And you can see it worked. I got my tax rate, which looks pretty much the same across the board. Another cool thing we can do, which I haven't covered yet, is we can create tables from within, obviously, our SQL code. So far, we've been querying and returning data frames, but what if we wanted to actually create tables? Let's start looking at different ways we can do this. Now, I want to point out that when you look at create table options, and there's a link here I give you to go look at those options, because Delta is pretty new and certain things they didn't factor in, I guess, with Delta, not all of the options work when you're creating a Delta table. So just be aware of that. So I'm going to say I want to create or replace a table, T sales info extract. I'm going to say it's using Delta, meaning I want this to be a Delta table. And I'm going to put the location down, which is AW Delta tables, and then the name of the table, so I know where it's going. That's something all new, but the query is the same one we ran earlier, so it's the same query overall. And we're just going to take the results of that query, and we want to store it as a table. So it's going to actually run this and put the results in this table. Let's run it. All right, so we ran the code, and it created our table for us. And we can confirm that by running a query here where we just pull a few rows off. And so we know we can query the table. There it is with regular old Spark SQL. The collect statements are interesting. Why are we doing the collect? Because as I mentioned earlier, in order to view and do things with the results, to force the Spark query to actually return the results, you need to force it to. And the collect statement says, I want you to do this now. So it forces it to do that. It's returning this as a list, not as a data frame, not even a Pandas data frame. So by default, it's returning a list of rows, it looks like, from what I'm seeing here. All right, so great. You can go in here and see what it did. Now, if I want to make it easier to look at, I can just wrap that data frame in a display statement. And even though it's a list, fortunately, Databricks notebooks handle it pretty nicely, and I can do all the usual visual stuff. But if I look and I want to say, but is it really a list or is it a Pandas data frame? I can confirm it by doing type, and it tells, yep, it's a list. It's a local list, okay? Now, what if I want to convert it to a Pandas data frame? Well, instead of saying collect, I just add on two pandas. That's all I got to do. Now, I'm putting it in the same name, lpdf underscore sales info, local, and local PDF, sales info. And let's see what happens here. Now, we can see it's an interesting thing. I didn't wrap it in a display, so it renders pretty nicely the way it would like in a Jupyter notebook. I can confirm it really is a Pandas data frame by doing a type statement, and there we see Pandas core data frame. Again, it's important to know these distinctions because as you start to use open source libraries, it becomes important. Now I can also use a method called the save as table method. Before I do this, I've been playing with this. I'll drop the table to make sure we don't have it. And I'm going to do this two different ways. I saw one example online I wanted to copy. I'm importing PySpark because I was getting errors when it didn't get imported. So I want to make sure I have it. Then I'm going to say from PySpark SQL, import dataframe writer. Dataframe writer allows us to access the save as table statement directly and use a particular format shown here to save the table. So what I'm going to be doing is I'm going to be using PySpark SQL dataframe writer. I'm going to take that method and pass in my data frame. I'm going to return it to a data frame writer object. Then I'm going to take the data frame writer object, and I'm really calling the save as table method, but I'm going to say partition by, and I wanted to partition the data by my sales territory key. I'm going to create a delta table, delta format. Override says just replace it if it's already there, just basically drop it and replace it. And then there's where I want it to go. So here's the name of where I'm putting it. So let me run this. And let's take a look in the folder. So this is the path I put it. Let's see what we actually get in that folder. So you can see because I partitioned, you get a separate subfolder for each partition value. And it's really easy to see what we're getting. It's basically by each value, each sales territory key value, you can see what it is. And it's a subfolder that stores the Parquet file. Let's take a look at getting information about the table. Did it really create a delta table? Did it work? So we get our normal stuff. We're using describe table extended because I want to see the properties below. And here we can see, yep, it created the name to the database. It shows us where it put it. It is a delta table and things like that. So we got a pretty good idea. Yes, it actually worked. That's great. Now I'm going to do this with another table. I'm just taking the same table name basically and putting a 2 at the end. I'm going to drop it first. This is a little different though. Instead of explicitly converting and creating a data frame writer, I'm just going to use the data frame, the PySpark data frame method. I'm going to say SPDF sales info, so that's my data frame. I'm going to use the write method, and then I'm going to say mode overwrite format Parquet. So I don't want to do delta this time. I want to do a Parquet, and then I give it the path as before, and then I'm going to say here save as table, kind of wrapped around. You can see it here. We'll run that. And let's take a look at the folder now. I want to look at the table folder. And you can see it shows you a bunch of stuff, but most importantly, the Parquet files. Now a key thing to notice that's different from these two is that when I look at these files, you'll notice you have something called a delta log. That's a subfolder that is tracking in JSON files consolidated periodically into checkpoint files in Parquet format, but it's tracking all of the different delta table modifications that have been applied. So it can roll them back, it can roll them forward, it can slice and dice and julienne your salad. It's got a lot of features. By adding that delta log, you get a lot of additional support and features for data recovery, for being able to do point-in-time snapshots, etc. With the Parquet, you don't get that. So when we go here, you don't see any logging. You just get the files. So these are good if you just want to dump files in. You want to maybe even you can partition them. You can do all kinds of stuff with Parquet, but you're not interested in really doing updates and merges, etc. Then this can be a good option. Delta really is just Parquet format, but with extra features like logging. And if I do a describe table extended here, get similar things, but main thing as I can see it is a Parquet format. Here's a cool thing you can do too. Maybe you got a data frame and you really don't want to persist it as a permanent table, but you'd like to be able to save it as something temporary in SQL so that you can manipulate it in the other languages, including SQL, R, and Scala. Well, one way you can do it that's been around for a long time is a method of a data frame called create or replace temp view. And by the way, all of these are case sensitive, so make sure you type them right. But create or replace temp view, and then you give it the name. Now the temporary view is, as it says, temporary. So when your session ends and you disconnect and nothing's looking at it, it goes away. But it's a great way within your notebook in particular to create a temporary view, and then you can use it from R and other languages. You can play with it and do what you want, and then just let it go away. So we're going to create one called TV temp view underscore sales info from the data frame we have. And let's just see if SQL can see it now. And by the way, what is a view? A view is just a query that looks like a table and acts like a table, but it's actually going to have to execute the query underneath it all the time. Now let's see if we can get from R. So we create an R cell. We do need to tell when we use a code cell in R what library we want to use, because there's two. There's Sparkly R and there's Spark R. So I'm going to tell it to use Spark R. I'm going to do then from there SQL select to see that I can call it and get at TV sales info. Limit 3 will just bring back a few rows. I'll use the display statement so it's pretty. And there it is. So it's a really important thing to realize. I created a view, temporary view, or tables as you've seen earlier, in Python, but they're accessible from R and Scala. And that's really important if you want to use different languages within your notebook. It's great for sharing with people with different skills. And here we can see the same thing. I'm just going to read this from Scala. And here you say Spark SQL. And the key thing with R when you're using it, there's no Spark SQL. R just says SQL and that's it. Not sure why they made that difference, but it can throw you for a loop here and there. And finally, before I wrap up, I do want to demonstrate that we can do aggregation queries, which is a really nice feature within SQL. What I mean is we want to get some aggregations by the sales territory key. Now normally I join and I get the sales territory name so it looks prettier, but I just to demonstrate using the key. I want to get how many sales are there? What's the total sales amount? And I'll rename it as total sales. What's the average sales amount? And on and on. I can do all kinds of things. There's a lot of cool stuff we can do here. But what I'm demonstrating is I can do all of this and it's going to group it by sales territory key. And the performance analyzer within Spark understands what you're doing and will optimize and do things to make this perform well. And then I'm just going to use the display to see the results. I've definitely driven home the point that there's a lot of advantages to using SQL with Python or R or whatever languages you use. However, we're going to see there's a lot of powerful features to also just using Python. So we'll cover that later. So please let me know what you think of this video, post your questions, etc. Do likes as usual. And remember, I'm posting a link also on my riveting book, Master Azure Databricks Step by Step, available on Amazon. Until next time, I'm pulling for you. We're all in this together. Thank you.